This is the year 2010. Work on the International Space Station is complete. Europe and its partners, the United States, Russia, Japan and Canada, have built the first international off-world platform for humanity, 400 kilometers above Earth. The aim is to press forward with technical and scientific research in a microgravity environment, work that cannot be done on Earth. The International Space Station has been inhabited since the year 2000 and is now well advanced. Since 2009, the crew of 3 has been increased to 6 astronauts. This amazing structure is 1.5 times the size of a football field. Its solar panels are visible from Earth. Its habitable space compares to an Airbus aircraft and includes 8 pressurized laboratory modules. This is the Columbus module, a multidisciplinary scientific laboratory built by the European Space Agency. Columbus will have instruments for hundreds of experiments, ranging from life sciences, material science and fluid physics, to research into solar-related phenomena. The inside of this European module contains easily interchangeable cabinets in which these scientific experiments will be performed. Taking advantage of this unique environment, with the absence of the effects of gravity, multidisciplinary research will be carried out in a variety of fields, including medicine, physics, and industrial manufacturing processes. This is an ATV or automated transfer vehicle. Also European-built, these unmanned cargo vessels are launched on Ariane 5 rockets from Kourou in French Guiana. 2 days after launch, ATV automatically docks with the space station and forms an integral part of it, in which the astronauts will be able to live and work. Capable of delivering a 9-ton payload, ATV carries experimental equipment and spare parts, as well as food, air and water for the permanent crew. The ATV will also be used to occasionally boost the space station and raise its altitude, since the station's orbit slowly decays due to the drag caused by the top layers of Earth's atmosphere. Node 2, another European-built element, is one of the 3 space station nodes which are interconnecting elements between the various pressurized modules. They provide a shirt-sleeve environment to allow astronauts and equipment to pass into other modules and provide vital functions and resources for the laboratories and living quarters attached to them. Node 2 provides electrical power distribution and thermal and environmental control, as well as being a connection point for the space station's European robotic arm, ERA. Here we catch a glimpse of ERA in action. Like the Canadian and Japanese arms, ERA will save the astronauts from having to go outside so often, and they'll be able to handle equipment and materials without having to put on their bulky spacesuits. Node 3 is the second European-built node and one of the last items added to complete the space station. Node 3 houses one of the most advanced life support systems ever flown into space, necessary to serve a permanent crew of 6, with enough recycled water to drink and oxygen to breathe. It will also contain an atmosphere revitalization system, which will clean the air and monitor air quality on the space station. Attached to Node 3 is another key part of European participation, the cupola, a sort of control tower set in the center of the space station. At 2 meters wide, the dome-like cupola is forged from a single 1.8-ton chunk of aluminium with slots for 6 windows and 1 large circular viewport that's the largest window so far flown in space. Up to 2 crew members can sit in this pressurized panoramic observation area to supervise the activities of the robot arms, approaching spacecraft, and astronauts operating outside the space station. For the international crew, this is also a window on our planet and on the universe. With the space station moving at 28,000 kilometers an hour and circling Earth every 90 minutes, the astronauts can use the cupola to track weather systems, make astronomical observations, or just watch our planet glide beneath them. In time to come, the International Space Station will serve as a vital springboard for future space exploration as we learn how to venture still further into the universe.